Alright, this is a review for Survey 4. Intro to stat. What is the distribution of values taken by all statistics and all possible values of the same size form of the population called? And that is what we've been doing, which is the sample distribution. That's the definition of sample distribution. To a random sample of 1,000 Americans found out that 62% were satisfied with the service provided by the dealer from which they bought the car. A simple random sample of 100 Canadians found that 59% were satisfied. The sampling variability associated with these statistics is, well, for the Americans, it's 0.62 times 1 minus 0.62 divided by 1,000. Which was 0.015. And for the Canadians, we got the square root of 59 times 1 minus 0.59 divided by 100, which gives us 0.049. And the main reason why this one is bigger is because smaller sample size. Number 3, in a large population, 54% of households own DVD recorders. A simple random sample of 100 households from this population are to be contacted and the sample proportion computed. Which of the following expressions represents the probability that more than half the households will own? So here's P equals 0.54. Sigma is equal to the square root of 0.54 times the 0.46 divided by 100. And here is, that was the mu of p hat. Here's p hat equaling 50. So we're looking for all of this stuff. So z has to be bigger than, well, z equals 0.5 minus 0.54 over the square root of 0.54 times 0.46 over 100, which is negative 0.8. And then we need z to be bigger than negative 0.8, so I'm going to use normal CDF from negative 0.8 to a billion, with the standard deviation 0.54, and whatever that was goes on the bottom. So I'm just going to type in the square root of 0.54 times 0.46 over 100. I'm sorry. The mean is 0 and the standard deviation is 1 because we have the z-score. Which gives me a percentage of 0.788. For problem number 4, in a opinion sample, 35% of a random sample of 170 people, what is the standard error? Well, it's p times 1 minus p over n, which means we got the square root of 0.35 times 1 minus 0.35 over 170. Which was about 0.037. For problem number 5, a marketing consultant wants to estimate the proportion of all shoppers at a certain mall who make at least one purchase. He stands at a mall exit for 2 hours on a weekday afternoon and flips a coin each time the shopper leaves. The coin comes up heads. He asks, After 2 hours, he has 132 responses. 128 of them made a purchase. So this is not an SRS because you have people leaving only one exit. I don't know if there's something special about that exit, but you need to have all of the exits covered if you're going to do it this way. Independence is probably fine because there's probably more than 132 times 10, which is 1320, which is less than the total shoppers at a mall in a given day. And then normality, we do 132 times 128 over 132, and we get 128. And we do 132 times 1 minus 128 over 132, which is 4. And because this number is less than 10, this also doesn't occur. So in this one we have normality and we have SRS both failing to be conditions that are met. In problem number 6, what does 99% confidence mean? It means that 99% of the time, with the way we collected the data, and did the math, we will get the right answer in our interval 99% of the time. Alright, once again in problem number 7, we're asking every 10th person in line, which means that this is not an SRS. So we need to pick the choice, since this is multiple choice, that gives us a simple random sample where everyone can get picked. In problem number 8, we talked about this 90% confidence interval. If you go up to a 95% confidence interval, I'll just call it CI for short, you get a bigger margin. And if you go up to a 99% CI, you get even a bigger margin. In problem number 9, we're going to do a normal CDF from 1.8 to a really big number with a mean of 0 and a standard deviation of 1. And then after I get this answer, I'm going to multiply that by 2 because the alternate hypothesis was P is not equal to 6.6, which means this is a two-way, which is why I'm multiplying by 2, which in this case was 0.072, and that's my p-value. The next video I do will have the other set. Let's just do an opinion poll, ask 100 people how they view their jobs, and 53 say good. Does the poll give convincing evidence? And so we are going to just do the hypothesis. So there's 2 hypotheses. The first one is P is equal to 40%, because it says that we want to conclude that more than 40%, so the first one is always equal to, and the second one, because it says more, is P is greater than 40%. I will do the other 3 problems on the next video.